All right, recording.
Okay, so this is the online makeup for the first lab of the year, which is the Baggy Lab. And Mr. Arroyo is going to lead us through the purpose.
The purpose for the lab is to observe physical and chemical changes and to formulate explanations by using logic and evidence.
Okay, and then for the description of setup, the chemical and physical changes in calcium chloride and sodium bicarbonate, also known as baking soda, will be analyzed when mixed with phenol red indicator and with each other. So I'm going to do a quick run through of the equipment list, some of the things that we're going to be using. The first one is calcium chloride, which you can see is kind of a dry, powdery substance. Some people say it looks like Dippin' Dots. Then phenol red indicator, which no surprise is red. Indicators are chemical substances that change different colors when they're in different pH environments. Sodium bicarbonate, which we said earlier, is basically baking soda. You're going to have a sealable sandwich baggie, just like a regular bag like you'd get from the grocery store for any typical sandwich. And of course, you're also going to use your safety goggles and your lab apron.
In addition to that, we have this graduated cylinder that you're going to make use of. The procedure has us measure a particular volume of water. We're going to make use of one beaker, and that's going to be helping us with the liquid phenol red. And in addition to that, to hold on to the white solids, we have two plastic weighing boats, one described as marked with a little dot in the corner and the other unmarked. We also have this clothespin. The clothespin is going to enable us to hang the baggie from the faucet during the appropriate step in the procedure. And we're protecting our clothing with the aprons. When we're getting the solid substances, we use this chemical scoop. The business end is the pointed end there as we get it from the jar. Our procedure has us start by obtaining 20 milliliters of water from the graduated cylinder. The graduated cylinder is what we use to measure accurate volumes as opposed to the beaker. Looking at that measurement for eye level, it's about 20 milliliters there. Pouring that into the beaker. That concludes step 1 and 2.
All right. The next step says to add 5 drops of the phenol red indicator to the beaker. And so whenever you use these droppers, make sure that you squeeze into the top so that you draw the liquid up into the dropper, and then hold them vertical over the beaker, and you're going to dispense 5 drops. So 1, 2, 3, 4, and 5. And then also in the instructions it says to give it a little bit of a swirl. So go ahead and just kind of swirl that up so it turns that nice pink color. That's exactly what you want.
The next step has us get a scoop of the calcium chloride. That's the Dippin' Dots white solid as previously described by Mr. Records. Holding the jar at the angle. It also says to put it into the marked weigh boat. So I have that one here. Getting that scoop in there, not too much, just enough to kind of cover the bottom of the plastic weigh boat. Go ahead and cover that back up once we're done with that. We also have the sodium bicarbonate, NaHCO3. Thank you, Mr. Records. Getting a scoop of that as well. Whoops. Put that into that plastic weigh boat.
All right. Now we're going to take the plastic baggie, and using my hand, I'm going to separate this into 2 separate compartments. Okay. And what we want to make sure is we know which side has got which chemical substance. So we're going to put the calcium chloride is going to go on the left side of the baggie, and the sodium bicarbonate is going to go on the right side. So very carefully, Mr. Rose is going to dump the calcium chloride in here on the left side. We typically need 2 people to do this because it's not a one-person operation.
Sodium bicarbonate.
Okay. And again, we just want to make sure that those move to the separate sides of the baggie and stay segregated from one another. Now what we're going to do is we're going to take the phenol red and water mixture. Remember, we got 20 milliliters, and Mr. Arroyo is going to use the graduated cylinder to measure out 10 milliliters, and 10 milliliters is going to be poured down on each side of the plastic baggie.
10 milliliters here. What side first, Mr. Records?
Calcium chloride. Okay.
Remainder should be the 10.
Okay. So you can see that's in there. And then 10 milliliters on the other side. Now I can tell those of you that are watching that this side with the calcium chloride feels very hot. Okay, I can definitely feel that temperature change occurring.
Asking Nasir, please report to the discipline office. Asking Nasir, please report to the discipline office.
What we want to do now is we're going to move this here over the sink so that it stays separated. And for a 3-minute time period, we're going to agitate these. And again, the side with the calcium chloride is feeling very warm. The side with the sodium bicarbonate feels very cool by comparison. So for 3 minutes, not allowing them to mix together, we have to agitate them continuously. So get that timer going. So it looks like we're about 15 seconds in.
During this process, you could be recording your data in the data table. So right now we have the calcium chloride and the sodium bicarbonate, and we've added the phenol red mixture. Again, Mr. Record said the side with the calcium chloride CaCl2 was very warm, and then the sodium bicarbonate, the NaHCO3, was very hot. When it comes to the physical versus the chemical change, you want to refer to your note-taking guide, and then based on the data that you've collected there with us, you're going to determine whether or not that change is physical or chemical.
Go ahead, stop this. Can we stop this?
No, keep it going. Make sure the timer's going though, because that's. Should have about 2 more minutes. Okay. So we definitely have a little bit of a color change on the calcium chloride side. Hopefully you can see that. How are we doing on time?
About another 30 seconds.
30 seconds. What we're going to do once the time is up is we're going to push all of the air, remaining air, out of the bag without letting them come in contact with one another. Then we're going to seal the bag, and once we seal the bag, we're going to allow both corners to come in contact with each other and react chemically. Remember that 3 of the things that you're going to see in this lab that are evidence for a chemical reaction are formation of bubbles, color change, and temperature change. Okay, and so you've seen a couple of those already, so just kind of keep that in mind.
You might want to also make note that we do have the calcium chloride side, is that correct, Mr. Records, in your left hand, has changed colors, no longer the red color, but more looks more like a pale yellow. So make sure you definitely add that to your data.
Okay, so we're at 3 minutes. Okay, so now we're going to push all the air out, and we got to make sure that we get a nice good seal here on the baggie. Thank you. Again, got to keep those from coming in contact with one another. And then what we're going to do is we're going to allow both sides to mix. So I'm going to pick it up here on the corner. and allow them to come in contact with each other. And I can look at it right away and I can see on the surface quite a few bubbles starting to form. Hopefully you can see that. And then we're going to hang that here on the...
a little bit higher. That's right.
Oops, there we go. We're going to hang that here off the sink. There we go, for 5 minutes and let that go and just kind of observe what happens. So again, bubbles you can see definitely are occurring. We had the temperature change earlier with the calcium chloride, and the color change that you saw earlier also with the calcium chloride and the phenol red mixture. Now this bag is going to hang here for a period of 5 minutes. So I'll let you kind of take a look at that.
During this time, you could either look at some of those questions. For example, in the analysis of questions, it does ask for those 4 signs of the chemical reaction, the fundamental difference between physical change and chemical change there. You could see also on page 2. And either answer some of those questions right now, or you could skip ahead to about 4 minutes from the current time in the video. So it's been about 5 minutes now, and there's been some changes to the baggie over time during that 5 minutes. Just kind of a recap. Initially there was a lot of bubbling during that initial reaction, and then it settled down a little bit, although there's still a little bit of bubbles clinging to the side of the baggie. But overall, after the reaction, it seems that we have two different layers. We have the liquid on top, and that liquid, as you can see with the video, is a pale yellow color. But also at the bottom, in the bottommost corner of the baggie, it looks like there's a white substance that's in that bottom corner. It's not a part of the liquid, it's separate from the liquid, and it does obviously have a different color. So we have this white substance in the bottom, and then the yellow liquid up on the top. We also have, it looks like, not too much, but a little bit of inflation of the baggie itself. Whereas we had squeezed out all of the air, there seems to be a little bit of gas that's trapped within the baggie right now. And not very much, but definitely more than we saw at the beginning when we had pushed all that air out. For cleanup here, it's a matter of getting rid of the substances. And they're safe chemicals to go ahead and wash down the drain. Every given lab has their own set of instructions for chemical disposal. Make sure you get those observations in there, again referring to your note-taking guide if necessary for physical versus chemical changes, and fill that in your data table as well. And that concludes the Introduction to Chemistry Baggy Lab makeup activity. Make sure you get that completed and turn it into your teacher on the day that the teacher indicates to you.